Hi everyone. Welcome to the new lecture in my playlist, Mastering Machine Learning from Basics. So this is lecture 1, and in this lecture we will familiarize different types of machine learning models. So we will cover the theory, mathematics and implementation in this lecture. And my name is Aishwarya Nandakumar. I am the co-founder of Togo AI Labs. So the goal of this lecture is to understand the different types of machine learning settings. So let us get started. So we will discuss about the two main types of machine learning models, which is supervised machine learning model and unsupervised machine learning models. So let us start with supervised learning. Here in this screen, you can see many images. We have the images of different lotus or different flowers, and we have the images of birds. So when we see these images, our brain is naturally able to tell this image is that of a bird or this image is of a flower. How is our brain able to do that? So, since when we were kids or when we were very young, our brain automatically got trained to analyze the different features of a flower or different features of a bird and tell, oh, that is a bird or this is a flower. So, we learned the features naturally. Our brain was trained to learn that. So similarly, in a supervised setting, we are training our computers or we are training the AI model to learn the features of the image and tell whether that is a flower or whether that is a bird, giving them a label to learn. So here we have the images of flowers and we have the images of birds. These images are the inputs. Let us represent them using X. And every image is associated with a label. So we are training the computer by telling that here you have the label for this image. So this is a flower. Here you have the image and here you have the label. Here you have the image and here you have the label. Similarly, every image has a label. So the labels here are flower, flower, bird, bird. So for every image, there is an associated label. And let us represent this label by using Y. And these are the outputs. Now, we will have many images like this with associated labels. So our machine learning model or the supervised learning model will get trained based on these labels. So if an image is composed of many pixels, our machine learning model will be able to learn the features of that pixel and tell that, okay, an image with these kinds of pixels or these kinds of relationship between the pixels is associated with this particular label. So this is the case of an image dataset. Now coming to another dataset where we have different blood glucose values. So if you are into medical field, you will be knowing, okay, the values, say 100 mg per deciliter is a normal value or less than that is a normal value. And I don't know the exact number. Say if it is greater than 150 mg per deciliter, then that is a high value. So here we have different values of blood glucose levels, which are the inputs, which we represent by using the letter X. And we have the different labels corresponding to every value, whether that is a normal value or whether that is a high value. So these are the labels or these are the outputs represented by using Y. Now, we will train our machine learning model. We will ask them to learn based on these input values and the labels or the output values, learn the relationship between these inputs and the outputs. And if we present a new value, say if it is 175 mg per dl, our machine learning model should be able to tell whether that is a normal value or whether that is a high value. So we are supervising our model to learn from the input and the output and extrapolate them to a new unseen value. This is how machine learning model or supervised machine learning model works. Let us consider another example that everyone can relate. Here we have emails, a data set of emails. Some of them are genuine emails that are not spam, and some of these are spam emails. So our supervised machine learning model will be able to learn the features, learn the relationship between the emails or the inputs and their labels, whether that is a spam or whether that is not spam. And based on the learned relationship, when there is a new email, our supervised machine learning model will be able to classify them into either of these categories, whether that email is spam or whether that email is genuine. So this is how a supervised machine learning model works. So now we discussed all these examples. Now the question is, how can we ask the AI model or the computer to learn the relationship between the inputs, the X, and the outputs, the Y's? So how we will ask the AI model to learn the relationship? How can we learn the relationship? So let us come to the mathematics or the theory part of it. We saw our image and the label, the flower, birds, dataset and their labels. We saw the blood glucose values and their labels. We saw the email and their label, whether that is a spam or not spam. So how can we generalize this and tell a dataset looks like this? How can we equate that? So in all of these cases, if you observe, you can see the dataset was in the format of input-output pairs. In every dataset, in all these datasets, in the image dataset, in the blood glucose values, or the email dataset, in all these, the dataset was in the form of input and output, input and output, input and output. It was an input-output pair dataset. So here we can generalize this data set and we can tell that in supervised machine learning setting, we will have a data set Dn equal to a set of input-output pairs x1, y1, x2, y2, x3, y3 till xn, yn if we have n input-output pairs. Here all the x corresponds to the inputs and all the y's corresponds to the outputs. The images, the blood glucose values, the emails, all of them were the X values or the input values. The corresponding labels, image of a flower and the label flower, image of a bird, the label bird. All those Y values correspond to the label values. The blood glucose value, the label, whether that is normal or not normal. The email, the genuine email with its label as not spam, the spam email with its label spam. All these existed in the form of input-output pair in our dataset. So we can generalize our dataset is like this in the form of input-output pairs in a supervised machine learning setting. And here we have n input-output pairs. How many images we have and all the corresponding labels of those images. So like that we have n input-output pairs in a supervised setting. Every input will be corresponding to an output or a label. And our model has to understand the relationship between the input and the output, the flower and the label, the bird and its label, or the image and its label, the email and its label, or the blood glucose value and its label. So the model has to understand the relationship between the input and the output pair, and it should be able to generalize this, and it should be able to extend that to unseen images or unseen input values that were not present during training. So here the image will be composed of many pixels stacked together, and there should be something that can map the relationship between these pixel values and the label. There will be some similarities, right, to tell whether this is a lotus and this is a rose. So all the roses will be having some similarity, some features associated with them. All the flower or the lotuses will be having some similarities or features that that our machine learning model can learn and tell, okay, this image is of a lotus and this image is of a rose. So what are these shared similarities or what are these common patterns or relationships? We are supervising our machine learning model to learn these features from the image and learn the relationship between the features and the output or the label. So how can a model learn this? In words, it is easy. It is easy to tell, okay, here our machine learning model is learning the feature or mapping the relationship between the input and the output. But mathematically, how is this possible? So our computer is only able to understand the mathematics. We have to write the code and we have to tell this is how you have to work. So how can we tell our computer to learn the relationship between the input and the output? There we can have a function to learn the input and the output relationship. So our goal is to the machine learning supervised machine learning model's goal is to learn a function f of x equal to y to map the input to the output using the training data. So all those data sets that we saw, the image dataset, the email dataset, the blood glucose level dataset, those were the training data. So using that training data, our supervised machine learning model should be able to learn a function f of x equal to y that can map the input to the output. So how is this possible? How can we tell our computer to learn like this? So we had a data set of images. Some of them were birds and some of them were flowers. Each image is an input and it has its corresponding label or the output. So these labels are correct labels. So if we imagine this as a question and answer pair, then the images are the questions and the labels or the outputs are the corresponding correct answers. Now we have this image and the correct answer, the image and its correct answer. We have the pairs. And our machine learning model will learn the question answer pairs or the image and the label pair, which is our input output pair. And it will be able to tell whether that is a flower or a bird when a new image is presented. So this is how the supervised machine learning model works. We are supervising the machine learning model to learn the relationship between the input or the images and the labels. And once the model is trained, the model can look at a new image and tell whether it is a flower or a bird. Because we presented during training many images with its corresponding correct answers. Now it learned the features from that question answer pairs, from the image label pairs, and it know how to learn the features and tell, okay, these features are the features that corresponds to a flower and these features are the features that corresponds to a bird. Now, when our model is supervised to learn the features from the images, after training, when a new image is presented, our model can look at that new image and tell whether that is a flower or a bird. Very interesting, right? Like we train a small kid. We present that small kid with many images or many objects and we are telling them, okay, look at this object. This is corresponding to that label. This is the image of a flower. This toy is a toy car. This is a refrigerator. So we are training that kid to see the objects and learn its corresponding labels. So when the kid sees a new bird, he can tell, oh, that is a bird. I know that. My brain is trained. Similarly, we are training our supervised machine learning model with labeled training data and we will present a new image or a new entity that was not present during training, but still our supervised machine learning model can see the features of that new entity and tell what is the label of that. It can classify. Very interesting, like how a small kid is learning to classify different objects that he sees. Now, essentially, when we summarize supervised machine learning model, essentially, our function f of x is learning, given this set of pixel values, is that a flower or a bird. So these pixel values are the input values or the input features, and that flower or a bird, that label is the y. So it is learning the relationship between x and y. So our model is classifying the images into different classes based on the relationship between the input and the output. So this is a classification problem. We call this a classification problem. In our case, we just had two classes, right? We had images of flowers and birds. We had entities or the glucose values which were normal and which were high. We had spam and not spam. So all of these were classification problems that involved only two classes. We call the classification problems with only two classes as binary classification problem. We just have two classes. So in a binary classification problem, we will have two classes and it will be like whether that is -1 or that is +1. If it is -1, then it corresponds to a flower, or if it is +1, it corresponds to a bird. So this -1 is a class and this +1 is a class. Another example is if we have images of MRI images of brain images. Some of them will be having brain tumor and some of them will be the images of healthy brain. So if we are training our supervised model to classify the images into two different classes, like images with brain tumor and images with healthy brain. Again, these are two classes. So it is another example of binary classification. Here, the -1 class is brain tumor and the +1 class is healthy brain. Another example is if our dataset consists of images of cats and dogs, and if we are classifying into two classes, cats and dogs, by training our supervised model, this becomes another example of binary classification problem. So what if we have multiple classes? What if we are classifying the brain images into three different classes? So suppose these brain images are the images of people who are suspecting dementia. So we can classify these brain images into three different classes, like the images that are non-demented, patients who are mildly demented, and patients who are highly demented. So this becomes a multi-class classification problem now. Unlike the two-class classification, now we have multiple classes to which we are classifying the brain images, and this becomes a multi-class classification problem. So basically, in this supervised setting, we will have a labeled data and we are supervising the training of the model to map the relationship between the input and the output using a function. So what can we call this function? So this function is essentially learning the relationship between the input and the output. So let us call this function learning function. Learning function maps the relationship between the input and the output using the labeled training data. This is how a supervised machine learning model works. Very interesting, isn't it? Now coming to an unsupervised learning. Here in unsupervised learning, we don't have input-output pairs. We don't have a learning function. So how can we ask our computer or the AI model to learn the features or learn the setting and classify a problem? So here we will have a data set. That data set will not have any labels, but we will ask our model to learn patterns from this data set to extract the structure or the hidden details from the data set and perform the classification or make the prediction. So how is this possible? Without having any label, without telling the computer, oh, this is the image of a bird. This image corresponds to a flower. These are the high blood glucose values and these are the normal blood glucose values. We are not telling any of this. We are just feeding the model a data set. The data set can contain many images. That data set can contain the different blood glucose values. That data set can contain different emails without any labels. So how can we ask a computer to learn the patterns or the features or the extract the hidden details from that data set and predict whether that is a flower or whether that is a normal brain or a brain with brain tumor, whether that is a normal blood glucose value or high blood glucose value? How can we ask the computer to learn the hidden details from that without telling the labels? Let us see. So a very good application or a very good example for an unsupervised machine learning setting is we can we can give our computer or the AI model the data of customers of a supermarket, of a mall, shopping mall. So these customers will be having some behavior, will be having some purchasing behaviors. So just by giving this customer data set, we are asking our machine learning, unsupervised machine learning model to cluster the customers based on their behavior. So some of these customers will be high paying capacity customers. Some of them will be frequent visitors. Some of them will be low paying capacity customers who just visit the mall, just look at the things, who will not spend much, but they will be some frequent customers. So how can we cluster there will be different behaviors like this. So how can we cluster the customers based on their purchasing behaviors? So if a machine learning model is given the data set without any labels, and if we are asking them to extract the hidden details or find out the pattern and cluster the customers based on this, then that is an unsupervised machine learning setting. There will not be any labels. There will not be any learning function to map the relationship between the input and the output. There will not be any labels associated with the data. So there will not be any input output pairs. So how will the unsupervised machine learning model cluster the customers? Let us see. Let us look into the implementation or a very good example of this. Okay, so now let us see how we can implement an unsupervised machine learning setting where we will be clustering the customers of a mall based on their purchasing behavior. So in this implementation, I want you to focus on learning how an unsupervised machine learning setting works. So we will not go into the details of the implementation. We will not understand every aspect of the code, but we will see how our machine learning model is automatically finding out the hidden structure or learning the patterns from the data, and it automatically clusters the customers. So here, the clustering of the customers of a shopping mall is based on their purchasing behavior. So here, how we are doing this is we have a data set where we have the details like customer ID, customer name, age, frequency of visit. That is how many times they visit per month and their spending score out of 100. And there are 4 clusters or 4 groups in this data set. The first one is the VIP customers who visit frequently and spend a lot. Then second is the frequent customers who visit frequently but spend a little. Then the third group or the third cluster is occasional luxury buyers who visit rarely but spend a lot. And a final one is the low value customers who visit rarely and spend little. Now, how we are training this ML model is this is unsupervised learning. So as we discussed, there won't be any input-output pairs. There won't be any labels. There will not be a learning function to map the input and the output. So the model discovers the hidden patterns and discovers the structure of our data. Now, what is clustering? So when we discussed supervised machine learning model, we discussed about classification, classifying the data into 2 or more classes. In clustering, we are grouping similar data points together. So customers with similar purchasing behaviors, they will be grouped together. So we know that there are 4 groups existing, but our machine learning model, we are not telling our machine learning model, these are the 4 groups that exist within this data. Instead, the model discovers them automatically. But we know that there are 4 different clusters or 4 different groups. And in this, we are using a very popular simple clustering method called as k-means clustering algorithm. So I'm not going into the depths of how k-means clustering algorithm is implemented in this lecture. In the upcoming lectures, we will be discussing that in detail, and we will see how we can implement k-means clustering algorithm detail in the upcoming lectures. So in this lecture, let us focus to understand how unsupervised machine learning model works. So after clustering, we will try to understand what each cluster means based on their feature values. So when I run this code, I'm not going into the details of this implementation. So when I run this code, it will automatically cluster the customers into the 4 different clusters. The VIP customers, the frequent customers, the occasional luxury buyers, and the low value customers. So let me run this code. So when I run this code, the model will automatically cluster the customers. So here is our sample data. So we have the customer ID here, customer names here, their age, their frequency of visit, and their spending score. So if you see here, we can see that this third person is 38 and he visits 26 times a month. His spending score is 81. Whereas the last 5th person who visits the mall 24 times a week, which is lesser compared to the third person, but his spending score is high. So when we cluster, this 5th person should belong to the class of VIP customer or who spends more than the third customer. So let us see how the clustering is happening. So here we have the clustering now. So it is like this. So here we have 4 clusters. These are the centroids of the clusters. So we can see the data set is very neatly clustered into 4 different groups or 4 different clusters with very distinct clustering, there is a very good distance. It is not mixed. We can see here. Let us see. Let us define the cluster names and see. Okay, so these are the frequent customers. Frequent customers who visit the mall frequently, but their spending score is less. These are our VIP customers who visit the mall very frequently and who spends a lot buying things. Then these are our low value customers who visit the mall very less often and who does not spend anything. And these are our occasional luxury buyers who visit the mall less often but buys a lot. So here we can see that the cluster centers of 4 clusters, their frequency of visit. So these are the cluster centers. Their frequency of visit is very distinct, right? So the cluster 0 is the VIP customers. So their frequency of visit, the average is 22.38. Their spending score average is 24.92. Cluster 1, what was the cluster 1? Let me see. The cluster 1 is the frequent customers. So the frequent customers, their frequency of visit is 4.92, which is very less compared to the first one. So there is some problem here regarding the frequency. But yeah, overall, the clustering algorithm worked well. Our model, we didn't tell there are 4 clusters existing within this data. We just fed the data to the unsupervised machine learning model, and it automatically, even though we knew that there are 4 groups or 4 clusters existing within the dataset, we didn't tell our model there are only 4 clusters, or these are the 4 clusters, these are the purchasing behaviors. We didn't tell any information like this to the machine learning model. We just fed the dataset and we asked the model to cluster the customers, and we got the output like this. So from the dataset alone, without giving any labels, without any information regarding the input-output pairs, without a learning function, our supervised machine learning algorithm was able to classify or cluster the customers based on their purchasing behaviors. This is how an unsupervised machine learning model works. So, in unsupervised learning, when we implemented our problem, we saw that we didn't tell the model, these are the groups, or you have to cluster the customers into 4 different groups. We didn't feed any input-output pairs, but result, we saw that our model very accurately clustered the customers into 4 different groups. How was this possible? In unsupervised machine learning setting, like clustering, the model organizes the data into groups. Like our model organized the data into 4 different groups by finding the patterns based on how close or similar the points are to each other. So when we implemented our example, the similarity was based on their spending score and the frequency of visit. We were clustering the model clustered the customers based on how frequently they visited the shopping mall and how much they spent when each time they visited. So based on this similarity or how close the points are to each other, these patterns are learned by the unsupervised machine learning model automatically. And based on these patterns, which the model automatically learned from the data, it clusters the data into groups or clusters and find the patterns. So here in unsupervised machine learning setting, the model's goal is to find the structure inside the data and group similar data points together based on patterns. Here the patterns was based on the spending score and the frequency of visit. So the model automatically learns groupings by looking at the similarity between the data points, how close or similar the points are to each other. So in real life, let me tell you one example that will help you to understand how unsupervised machine learning setting works. When you go to a party, how you will find out that when you see a group, how you will tell that these two are more friendly, or maybe they are the best friends. Or if you are in a classroom, how you will be able to identify the friends in the classroom. So naturally, our brain can analyze the friendships or the groups in the classroom or in a party, right? We can figure out, okay, these are the friends in the group. These are the groups that exist within a university or a class or a party. So our brain here is automatically finding out the patterns inside every group based on the similarity, how frequently we communicate. So there are many hidden patterns. There are many hidden patterns within groups. So here in unsupervised machine learning setting also, the model is grouping the data points into different groups based on the similarities and the hidden structures. So how close each points are based on these based on these similarities. So this our model is automatically learning, and finally we will get our clusters. This is also very interesting, right? So I hope this lecture on supervised and unsupervised machine learning models was very clear and interesting. In the upcoming lectures, we will discuss more on other types of machine learning models like reinforcement learning, and we will also see some in-depth explanations for supervised and unsupervised machine learning models, and we will also implement both of these in detail. So stay tuned for the upcoming videos. I hope this video was very useful. All of you enjoyed it. Thank you so much.